Hello all, this is Dr. P. Shyamsundar, Associate Professor, Department of Electronics and Communication Engineering, KL deemed to be University. In the previous session, I have shown you the comparison of graph between gain AV and gain AVS. That means V0 by Vi and V0 by Vs. In this session, let us see the effect of capacitors. There are three capacitors we have connected, of which we cannot see the effect of capacitor CC2 directly, but I will show you the effects of the capacitor CC1 as well as bypass capacitor CE, so that what are the effects it is showing on the frequency response curve of CE amplifier. Let us dive into it directly. I'll go to AC sweep. I'll go here, simulation and analysis. I'll go with parameter sweep here. I am introducing you to a new analysis technique, parameter sweep. Just click on parameter sweep. You can see that you are having 4 tabs as you saw in AC sweep: analysis parameters, output, analysis options, and summary. Here, the sweep parameters: device parameter, model parameter, or circuit parameter. Let us choose the device parameter as we are choosing the capacitor. Next, sweep variation type will be either decade or linear or octave or list. So here we are choosing a linear sweep type because whatever capacitor value we are varying, let us vary linearly. Now device type, there are various devices connected: BJT, capacitor, resistor, and source. Whatever components we have used to connect the circuit here, they are source, resistors, capacitors, and BJT. That's all. So out of these devices, I am choosing capacitor. Which capacitor I want to change? Which capacitor value I want to change and observe the output? I want to change the bypass capacitor value CE. So I will choose CE. It will show all the capacitors connected in the circuit. CC1, CC2 both are coupling capacitors. CE is the bypass capacitor. I will see the effect of CE. And if you want to see the effect of variation of capacitance CE, what are the parameters a capacitance can have? You see, whether it's capacitance or its current or its sensitivity or length or temperature coefficient or temperature or width. All these parameters you can vary in this capacitor. I just want to vary the capacitance of emitter bypass capacitor. I want to see what if a capacitor is connected, how the gain is, and if the capacitor is removed, how the gain is. That means with and without the emitter bypass capacitor. For that purpose, I want to take only two values. Once it is connected, once it is disconnected. So start value of the capacitor, I will choose 0 microfarad. Stop value 1 microfarad. And number of points, I will choose 2. Only 2 points I am choosing. Right. Now, analysis to sweep, AC sweep. Let us see clearly. Start value 0 microfarad. 0 microfarad means what is the capacitive reactance offered? Capacitive reactance XC equal to 1 by j omega C. And when C is equal to 0 microfarad, XC is infinity, which implies open circuit. That means for that value of 0 microfarad, I am showing it as an open circuit of a capacitor. That means the emitter bypass capacitor is removed. Without that emitter bypass capacitor, I am going to obtain the gain for 0 microfarad. The second one is 100 microfarad, where the capacitor is connected. That means you are going to see the frequency response with the capacitor. So only these two values I am verifying. Now let us go to analysis to sweep. So I want to observe the frequency response. You have DC operating point, AC sweep, single frequency AC, transient, and nested sweep. So I want to go with AC sweep because I want to observe the frequency response with and without emitter bypass capacitor. Now go to edit analysis. It will show you the AC sweep parameters here in this pop-up window. Start frequency as usual 1 Hz to 1 GHz I am taking. Start frequency 1 Hz, stop frequency 1 GHz. Sweep type I am choosing it as decade. Number of points per decade are 10. Vertical scale, choose decibel scale. Now frequency parameters are over. Click on OK. We have to verify the output. So output I am choosing V8 by V2. You can even choose V8 by V4, anything. Let us choose V8 by V2 and I am running it. Just I am closing the cursors. I am just removing the cursors. Change the background to white. Select the phase plot and delete it. Now I am having a magnitude plot only. Double click on each, increase the width so that you can see the graphs clearly. Okay. If you see the legend of it, V8 by V2 green line, whatever green plot is there, this is for capacitance 0 microfarad. Means if you remove the bypass capacitor, you can observe that the gain is decreased and the bandwidth is increased. And for the blue graph, capacitance is 100 microfarad where the gain is more and the bandwidth is less. Based on this, you can clearly say when the emitter bypass capacitor is removed, the gain is reduced and bandwidth is increased. If we can recall, the gain bandwidth product must be constant. So if gain decreases, bandwidth should increase. If gain increases, bandwidth should decrease. By removing the emitter bypass capacitor, whatever current is flowing through the emitter resistance, this acts as a feedback to the input loop of the CE amplifier circuit. This acts as feedback. If I remove this, whatever current is flowing through the emitter resistor acts as feedback in the input loop of the circuit, which results in a negative feedback. Therefore, removing of this emitter bypass capacitor introduces a negative feedback in the CE amplifier circuit. By incorporating negative feedback, gain is decreased by a factor of 1 plus A beta and bandwidth is increased by a factor of 1 plus A beta. The purpose of including a negative feedback is to stabilize the gain, to stabilize the circuit. If you introduce a negative feedback into the circuit will be more stabilized. So if you go to the cursors part, you are having two cursors. You can go to the maximum value, go to 3 dB less value for green or blue. Now I have chosen the blue one. So whatever manipulations I do here, they pertain to with capacitor graph. Go to next Ymax. It will go to the Ymax of blue graph, and that value is Y2 here. It is Y1. Y1 is about 44.25 dB. Now right click on this, set Y value 41.25. I am making it as 41.25. It has gone to 41.25. Now I am right clicking this, set Y value, choose it as 41.25. Click on OK. You can clearly see that DX value is 69.12 megahertz. Okay, 69.12 megahertz. Now for the same, I will go back and I will just select the green color one without capacitor, without bypass capacitor. Right click, go to next Y max. It will show the max value here, which is about 10 dB, 10.9 dB. 10.99 is approximately equal to 11. So you are getting 11 dB gain. Right click on it, set Y value. it becomes 7.99 dB. It is somewhere over here. Right click on this cursor, set Y value 7.99 dB. Now you can clearly see the value of dx to be 83.87 megahertz. Earlier it was 69.6 megahertz. Now it is 83.87 megahertz, and clearly you can see that the bandwidth is increased. Gain is decreased and bandwidth is increased. So this is the comparison of the frequency response with and without emitter bypass capacitor. That means we are verifying the frequency response of current series feedback amplifier also. That means by removing the bypass capacitor, the result is current series feedback amplifier. Thank you.